Okay, so we are moving on to Chapter 3, Section 6, which is problem solving using charts. We're also going to look at 3.7, which uses those charts to solve specific types of problems. So you have the worksheet in front of me. Follow along. Pause when you need to fill things in. I'll also ask you to pause specifically to try some problems on your own, and then you'll be all set. So when you have lots of information, sometimes a chart makes it easier to identify what the information is and get it all ordered so that you can put things into an equation. So let's look at the first example. Organize the given information in a chart. First, it says, in game 1, Jesse scored twice as many points as Ramon. So in order to figure out what's going here, we need to talk about variables for Jesse and Ramon. So Jesse scored twice as many points as Ramon. That means Ramon is going to be our N or X or whatever letter you want to call it. And that Jesse, twice as many would be 2N. The other thing we know is that if we keep reading, in game 2, Jesse scored 6 fewer points than he did in game 1. So we would take what we wrote down for game 1, and 6 fewer means subtract 6. So we now have 2n minus 6. Keep reading. In game 2, Ramon scored 8 more points than he did in game 1. So what did we have for game 1? That was n. 8 more we know means plus 8. So for Ramon in game 2, we would have n plus 8. Now, if they had given us some more information, we could set up an equation using the information that we have in our chart, and we could solve for the number of points that Ramon earned. But they didn't. All we had to do was fill in the chart. So second example, solve the problem using the two given facts. Find the number of calories in a banana and in a peach. First fact, a banana contains 65 calories more than a peach. So we can look at the table that's provided, and if you think about it, when we want to find the number of calories, if we have a total number of calories and if we have a total number of fruit, then we can set up a relationship between the calories per fruit, the number of fruit, and the total calories. So that's what's going on across the top of this chart right here. Calories times number of fruit equals total calories. And in fact, you'll see that a lot. So you'll usually have something times the number of things equals the total. Some value times the number of things equals the total. All right, so first fact, a banana contains 65 calories more than a peach. So that means we're going to call peach this this variable, whatever we want to call it. In this case, it's P. And bananas, 65 calories more than a peach, so that means bananas are going to be P plus 65. All right, then it tells us that 10 peaches have fewer calories than 4 bananas. So how many peaches do we have? Well, we have 10, so we just write 10. And how many bananas do we have? Well, there are 4, so you just write 4. Then if you want to figure out the total number of calories, well, for peaches, it would be the calories per fruit times how many fruit you have. Well, if you have 10 fruits and the calories is P, multiply those together and you get 10P. Then if you want to do the same for bananas, you would multiply P plus 65 times 4 because that would give you the total number of fruits. Okay. So the next thing we're going to do is we're going to think about an equation here. So they tell us that the calories in 10 peaches equals the calories in 4 bananas minus 50, because 10 peaches have 50 fewer calories than 4 bananas. So that little sentence there is kind of a good way for us to think about the problem. And then we can go ahead and set up an equation. So we took this last column here, and we wrote a relationship between them. So 10 peaches is going to be equal to the calories in 4 bananas minus 50. There's our equation. Distribute the 4 math, 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 algebra, algebra, and you end up getting P equals 35, and then you could add 65 to get 100. The last thing to do would be to sort of check to see if that works. So we're saying that peaches have 35 calories per peach and bananas have 100 calories per banana. So you could kind of check it out and see if that actually works for you. All right, next. Let's do this first example together. So find the number of full 8-hour shifts that Clio worked last month. So here are the two things that we know. We know that Clio worked 3 times as many 8-hour shifts as 6-hour shifts, and he worked a total of 180 hours. So for a 6-hour shift, how many hours are in a 6-hour shift? Well, 6. How many hours are in an 8-hour shift? Well, 8. Okay. Then for number of shifts, we don't know how many 6-hour shifts he worked, so we put X there, and it tells us that he worked 3 times as many 8-hour shifts as 6-hour shifts. So 3 times as many means 3X, so 3X goes in this blank. Then, following the pattern across the top, so we've got hours per shift times number of shifts equals hours worked. So across the top, we would have 6X. Then we would have 8 times 3X, which is 24X. And here's where we can use our extra piece of information that he worked a total of 180 hours. So for that, we know the 6-hour shifts plus the 8-hour shifts are going to equal a total of 180 hours. And go ahead and pause the video here and solve that for yourself. Okay, so once you solved it, you should have realized, or you should have gotten X equals 6, but the question was about 8-hour shifts. So we go back to our chart, and we know that in relationship to X, an 8-hour shift was 3X, so 3 times 6 gives us 18, so he worked 18 8-hour shifts. All right, there you go. That's your example. Let's scroll down and move on to the next part. So now that we know how to do these equations using a chart, let's do some specific examples. So as I said, charts are a good way to organize your information, and there are sort of 3 different types of problems that all fall into the same category. I like to call them the cost of things, number of things problems, and usually it's cost, income, and value. So if you were thinking about the price of stuff, like if you wanted to buy candy and the candy was 10 cents a piece, if you had 50 cents, how many pieces could you buy? Well, or think about it this way, if you want to buy candy that's 10 cents a piece and you buy 5 items, what's your total cost? So these equations at the top of the page here, they all basically are the same thing. There's a number of items times the price of items, and that's going to equal the total cost. Or the hours worked times how much you get paid per hour equals the total amount of money that you earn. Or a number of items times the value of the thing equals the total value of whatever you've got. So these problems all sort of fall into the same category. And all the charts are going to look basically the same. So there's going to be a column for number of things, there's going to be a column for price of things, and then there's going to be a column for total cost. Now the thing that doesn't show up on this is there's actually an extra box that I would like you to draw down here, because this box is where we're going to put our total, overall total that we read about in the problem. Okay? All right, so let's read this problem. Tickets for a concert cost $8 for adults and $4 for students. So using our chart, what's the price per ticket for adults? Go ahead and fill it in. Okay, you should have done adults are $8, students are $4. Then the next part is it tells us that there are a total of 920 tickets. So we're trying to figure out how many adult tickets were sold. So let's make that our variable. So adult tickets is going to equal X. And then since there are 920 tickets total, we know that if we've used up X of them, then the leftovers would be 920 minus X. So that's what we write for our student tickets. 920 minus X. Okay. All right. Then all we need to do is multiply across in order to get the total cost. So for an adult, if we multiply 8 times X, we get 8X. Then if we multiply across with the 920 minus X times 4, we get, 4 times 920 minus X. Now this little box down in the bottom, notice that when we kept reading, it said the total of 920 tickets were worth $5,760. So that special box at the bottom is where I would put my 5,760, because that's how I'm going to write my equation. I'm going to take this whole part and just say, okay, adult tickets plus student tickets is going to equal 5,760. So go ahead and write your equation. Adult tickets plus student tickets equals 5,760, and then solve it. Pause the video here to do that on your own. All right, so you solved it yourself. There's the work. And you should have gotten 520 adult tickets. Then when you subtract that from 920, there are 400 student tickets. And you can go ahead and you can check it, because you could say, all right, adult tickets are worth $8 per ticket and student tickets are worth $4 per ticket. Multiply those things out. So 8 times 520 and 4 times 400. And if you add them, you should get the total, $5,760. If you don't, then you need to check again. All right, let's move on to the first example. Okay, our first example says 40 students bought caps at the baseball game. Plain caps cost $4 each and deluxe ones cost $6 each. If the total bill was $236, how many students bought the deluxe cap? So the first thing I'm going to do is I'm going to add my bottom box there, and I'm going to put in the total, which is $236. All right, so let's go back. Plain caps are $4 and deluxe are $6. So for the price, for deluxe, I put 6. For plain, I put 4. All right. Then they told me how many caps were sold total, or at least they told me how many students bought caps, which was 40. So if deluxe caps is D, because that's what I was looking for, so that's what I'm going to make the variable, then the number of plain caps is going to be the total minus what I've already used up, which is D. So 40 minus D. 40 minus D. All right, then we're going to multiply across. So multiply across the top row, you get 6D. Multiply across the next row, you get 4 times 40 minus D. To write your equation, you just add those things together and set them equal to 236. So, sorry it's down here, but 6D plus 4 times 40 minus D equals 236. Okay, pause here, do the math, and come up with your answer for D. All right, in solving it, you should have gotten that 38 students bought the deluxe caps. Okay, that's it for the examples. Thanks so much.